What up, Mad Leaves? Whoop, whoop. All right, let's get down to this. This is 12.4, our final kind of study day on it. We've taken it real low and slow on this. We're going to talk about flow and paragraph proofs. Your learning target is I will use flow and paragraph proofs to construct logical arguments, right? Makes sense? And again, as always, as I go through this, I'll say pause it. Those are your chances to pause it, do the work, move on, just like now. I'm going to say, all right, write down your learning target. Go ahead and pause it. See if you can work this out on your own. The warm-up, it's a two-column proof. All you're really doing is giving the reasons. So reset, go. All right. Assuming you pause it here. Okay, so what does it say? It says given JK, segment JK is congruent to segment LM. Okay, all right. Prove W equals 3.5. Sounds like a good deal. We start off right here with segment JK is congruent to segment LM. Okay, well, that's just our given, right? So let's cross that out, given. And then it says JK equals LM. Well, that's what it means to be congruent. That's definition of congruence. And I shorthand it, definition of congruence. Okay? And then we know that JK is 4W plus 1. And we know that LM is 6W minus 6. So we're going to substitute in those equations for the line segments, right? So this is substitution. Or the substitution property. I'm just going to write substitution. And then what are we going to do here? You'll notice we now just have 6W over here where we had a minus 6. We added 6 to both sides. So that's the addition property. Oh. So addition property, right? And then what did we do in between these two steps? Well, we subtracted 4W from both sides. So that's the subtraction property, right? And last but not least, we divided both sides by 2, so that would be the division property. And you'll notice we're left with 3.5 equals W. We want to, instead to prove that W equals 3.5, you actually have to be specific, so we're going to flip sides. And the symmetric property tells me I can flip sides and it's still equal. So the symmetric property. Awesome. Hopefully you were able to bust through that. Good job. And now we're going to talk about flow proofs. So, all right, we're going to revisit a proof we've already done, but I want to do it flow style to show you that it's very similar. And yet it does take on some different aspects, as we'll see later. But given Q is the midpoint of PR, of segment PR, right? It's a line segment. And we want to prove that segment PQ is congruent to segment QR. You may recognize this is the exact proof we did with two-column proofs a couple lessons ago. And I'm going to draw this out. You always want to draw it out if I don't give it to you. So we have segment PR here, and we have Q in the middle. And we're telling you Q is the midpoint. And so first things first, in a flow proof, you kind of make these little boxes or circles or ovals, which I've made here. And I'm just going to write what we have. We have Q is midpoint of, and this should be PR, segment PR. And this is our given. You just write the reason right below it. And now I'm going to draw an arrow to where we go next. Sometimes a given has more than one implication, so I may draw an arrow somewhere else. But in this case, we're just having a pretty straightforward. So what does that mean? Well, if it's the midpoint, that means that PQ equals QR. How do we know that? That's the definition of a midpoint. Then again, we're just going to carry this thought down here. And from there, I can immediately say, well, if that's true, then segment PQ is congruent to QR. And why is that? That is because that's the definition of congruence, to be equal to each other. Boom. And that's the basic idea of a flow proof. It really, unless you have some branching paths, it really looks just like kind of a differently organized two-column proof. A lot of people tend to like the flow proofs, kind of how your flow of thought goes. So we're going to come over here. Let's try another one. Given P is the midpoint of JK, segment JK, we want to prove that X equals 2. And I'm going to help you draw this, because the drawing came along with this, as you can imagine. And that drawing should just be, we got J, and we've got K, and we've got P, and JP, we're going to label X, and PK, that's a terrible K, but there we go. PK is going to be labeled 5x minus 8. All right, so this is a little bit different type of proof. So P is the midpoint of JK, of segment JK, that is the given. Then by the midpoint theorem, here's what we know. We know that JP is, segment JP is congruent to segment PK. Right? And how do we know that? We know that by the midpoint theorem. It's really supposed to be outside here, but I don't have a lot of room there. I'm going to write it right here, midpoint theorem. So imagine this is a little box that contains just our statement, and then we have underneath it. I'll do that for the next one. So what do we have then? JP equals PK. That's definition of congruence, right? To be congruent means they're equal to each other. And now I'm going to write in, right, X equals 5x minus 8. Why? Well, if these sides are equal to each other, then I can set them equal to each other. We're going to box that up. And that was substitution. All I did is substitute the value for JP, which is X, and the value for PK, which is 5x minus 8. So that's substitution. And then let's follow it over here. All right, what are we going to do? Well, it looks like we're going to subtract 5x from both sides, and that's the subtraction property. When we do that, x minus 5x is going to get us negative 4x equals negative 8. And then we're going to, and by the way, that is substitution. When you solve it out, when you're doing a flow proof, you need to actually write out what you're doing. Now, I'll typically write it out vertically, so I would write like the minus 5x underneath. But you have to tell it what you're doing. It's a subtraction property, and then we actually do the subtraction and adjust it, and that's substitution again, because when we do x minus 5x, we're substituting negative 4x for that. Then let's follow that down. What do we have here? We're going to divide both sides by negative 4, and now let's write it out again. Negative 4 divided by negative 4 just leaves me with x equals negative 4 divided, or negative 8 divided by negative 4 is positive 2. We see that x equals 2, and how were we able to write that in? That was substitution again, okay? So remember, when you're solving these out, you solve it through substitution. Awesome, that's a flow proof. Very similar, that's why I'm not taking a lot of time on it. I actually really like this flow. It's kind of nice. And notice, when we had to go to a new column, we drew this nice little line showing where we were going. You always draw arrows indicating where the proof is flowing, okay? All right, last but